tape with this new thing, so you know that you can be heard. So watch it. That's right. I made you talk, and then okay. All right. So grade school. At least before Common Core, where they try to make division even more complicated. Sorry, I have a 5th grader. She cries every night when she's doing math. It's great. Anyway, how do I divide 32 into 3587? What do I do? Well, the first thing, I already have the answer up here, but we'll analyze it because I swear to whatever you believe in, polynomial division is just as easy as this. All it is just some extra algebra skills. Now look at me that way, it's true. Okay, now, 32. How many times does 32 go into 3? None, but 35. 1, and that's why you have a 1 up above here. So then what do you do with this one? You multiply it, and then what do? Subtract it. So these are the steps, the skills that we're going to use from grade school for polynomial division. Everyone forgets the subtract part. Okay, and then you subtract, you get 3, then you bring the 8, you don't really need the 7. Because 32 go into 38, how many times? Once. Multiply, put it down here, but then what? Everyone say it. Subtract. Did you hear that, YouTube? 3 students. Must be a small class. All right, 38 minus 32 is 6, then you bring down to 7. And then 2 times 32 is 64. What do? Say it. Subtract. This is the number one thing that's missed or messed up. And then what do we do with 3? What's 3 called? Remainder. When you first were in grade school, that's all you did. R3. 3rd grade, 4th grade. I can't remember when my 5th grader did this. All right, but then you learned you could write this as 112 and then do what? All right, what? No, I'm sorry, it wasn't you. You could say plus 3 over, and I like that. And then you learned that you could just write this as 112 and 3 over 32. Do you know what and means anyway? What's and mean? Plus. So it really does mean that. I'm going to use that on the next one. That's great. Okay, so you learn how to write this as a mixed number. I was getting nervous that I didn't know what that was. All right. Scared. Okay, so now we go to this. I'm going to call on somebody. So, what do you do here? And it's the same thing. You analyze this, though. And okay, what are we doing? We're taking this divided by this. All right? But you focus on only the top dog degrees of each one of these. And then you play your grade school game. What times this equals this? And I don't care about anything else. Answer that question. Not, you're right, I'm sorry. 1x squared. But then what do? In grade school you took this and did what? Multiply. But this is no longer grade school. How do I take 1x squared times 3x plus 2? I distribute it. So one minor difference. One algebra stretch. That's algebra 1, by the way. All right, and then what do? You say it. Subtract. How do I subtract a binomial? I distributes. This is not hard. Students that make that hard, it isn't. And then 5x squared minus, the distribution of the minus sign is the biggest mistake people make. And of course, if you mess that up, the whole rest of the question's screwed up. You understand that. Next, now I focus on this, and I'm not doing the lines anymore. What times this equals this? X. But then you distribute, and then you subtract, but you do what with that subtraction sign? Distribute it. We're killing me here, Smalls. That's everybody. All right? And then you subtract. And then next group, let's pause for 2. And then what goes in this right here? That's blocked out.
6x plus 4.
And then subtract. So you get a 3. So when you distribute a negative, you get a 3. And then what do we say we do with that remainder? The remainder we make a actually rational expression, believe it or not. But remember what you said? What did you do with your remainder? you added it, and you have to do this. You can't just attach this to the 2. So you have to put a plus, and then 3 over what? What do we put? 3 over what? 3x plus 2. So it's no longer a polynomial. This is actually turned into kind of a rational expression idea, but who cares? All right, so you get the idea. Here's something that you're going to need to write down. Read your stinking directions today, because there are 2 forms of the way you can write your answer. One is called polynomial form. Can you say polynomial form? Apparently I can't. I'm fumbling it. All right, here's polynomial form. We'll look at the grade school example. You take your divisor, isn't that right? The number you divided by. Multiply it by the quotient plus the remainder, and that equals the dividend. Okay, so that actually, it's right up here. I just realized. I wasn't even looking at those words. That was easy. Okay, so when they ask you, and it's kind of silly, but follow your directions. If they say, divide these, put your answer in polynomial form, then this is the answer. Okay? Divisor times quotient plus remainder. Actually, this is the answer. You don't have to rewrite the, what you divided into. Okay? Or you do what we just did, which is, write it in what's called fraction form, taking the remainder and putting it over the divisor at the end as the last term, if you want to call it that. So I'll let you take that down and pause for.
Is it like a team?
Oh yeah, yep. All right, silence. The kids are going crazy. All right, I'm going to do one more, but here's the reason. Because do you know the other way you can divide? Someone say it out loud. What's the other way you can divide? Synthetically. Okay, I'm going to use this example to come back to synthetic division. So actually, offline, I don't think we have to have this tape. We'll just show the answer. Oh boy. All right, so we got through all of this, and then when we subtract, get these colors going. This is 2 over 2. So what's negative 2 over 2 minus another 7 over 2? Negative 9 over 2. Now, this is illegal. One of my favorite new terms. You cannot do this unless you like red pen on your paper. Negative 9 halves over 2x plus 1 as the final answer for the last part of this polynomial. Why? It's ugly, that's why. What can happen? What would the answer be? I have your hand going up. Go ahead. What would the cleaned up answer be? The simplified answer for this be?
Have negative 9 over 4x plus 2.
Ooh, and he already distributed as well. You are correct. I think when I wrote it here, I left it as a multiplied factor out in front. Correct. You should never leave a fraction within a fraction in a final answer. You need to simplify it. The best way I can describe this is division. So this means negative 9 halves divided by 2x plus 1, which is times 1 over 2x plus 1. And then when you multiply fractions, you multiply across. So that's the reason that 2 needs to be on the bottom. Unacceptable if you don't. Now, we're going to come back to this when I show you the connection with synthetic division. But do keep in mind in this one that I'm not going to do, it's actually a good idea when I'm dividing into x cubed minus 1 to leave spaces for the missing terms. So write them as 0x squared and then 0x, and then go ahead and go through a long division process. By the way, what about synthetic division in number 2? Do I have to account for missing terms or not? Do you remember that from last year? If you like right answers, you have to account for missing terms. So now what we're going to do is one more long division. No, we're not. You can actually just look at this. Look at it later if you want, and then accept that I've done the right thing long divisionally, if I can make up a word. That when I take 2x to the 4th blah and divide it by x minus 3, work, the answer is 2x to the 3rd plus x plus 10x plus 27 with a remainder of 82. And then what we're going to do is go ahead and watch what happens when we do this process called synthetic division. First step, though, is over here, and this is what you might want to write as a student. Hey, that's you. When you synthetically divide by the factor x minus 3, the first step of synthetic division is to turn the factor into a 0. You synthetically divide by the 0 counterpart of the factor. So basically, you just take x minus 3 and set it equal to 0 and solve if you really need to do that. Then you take the coefficients of the dividend and write them in descending order. And you're going to synthetically divide by 3. Now, you may or may not remember this. How many people remember this? Raise your hand. Because last hour, well, second hour, first of all, they drove me nuts. A lot of craziness, a bunch of dropping the things. They did it all organized together. Let's annoy Mr. Samuel stay. But then they also complained about this. Can you believe this? How many people like the synthetic division that remember it? Raise your hand. Good. Second hour people. You know how much I hate talking about other hours. But anyway. So what do I do first? What do I do first, those that remember? Yes, sir. Drop the 2 down. That's the starter. You just do it. Then what do you do? Let me change colors. I just want to be, yeah. Then what do? You take this 3 and do what with it? Multiply it by 2, and then add that to this. By the way, 2, 1. Let's keep going. Then what do you do with this 1? You multiply it. What's 3 times 1? No time 3. I don't know where everyone went. What's 3 plus 7? 10, by the way. What's 3 times 10? 30 plus negative 3. By the way. And then what's 3 times 27? I bet you it's 81. Because, by the way. Bloop. And then what you need to do as a student is understand, okay, I do the synthetic division process. I now have what's called a depressed polynomial. You know, I don't know why it's depressed. Because it used to be an x to the 4th. Now what is it? It's an x to the 3rd. It's not what it used to be. It's a shadow of its former self, just like Mr. Samuel's. What? 1x squared. Sorry, the poor kids. Common Core is killing them. All right, now, what do I do with that 82, of course? What do I do with that 82? Put it over. Do I put it over 3? No, you put it over x minus 3, and understand that this is kind of a trick in order to do something a little bit faster. Okay, now, we remember this from last year now, right, everybody? Okay, so I guess I'll do one more, but then what I'm going to do is that I'm going to jump back to this one because we're in honors. I'm going to jump back to 4, and I bet you can handle how you actually could synthetically divide number 4 if you understand something. And then we can make it an only statement. But let's go back to this one. What's weird about this one is, what am I dividing by? 4 minus x. All right? I think what would be smart is to turn that into x minus 4. How do I do that, though? How do I turn that into x minus 4? I pull out a negative. And then, all kidding aside, second hour, but they didn't understand this. You know what I could do with that negative 1? I could basically just move it. And then this is what I had to write. And I'll write it for you. Is negative 1/2 equal to negative 1 over positive 2, true or false? Well, is it equal to 1 over negative 2, true or false? So can I just move the negative where I want? Yes, I can. So I factor out a negative out of the bottom and I shove it up into the top. And then I distribute it. And then, by the way, you can see I already did that, and then I accounted for what? What did I account for? Missing terms. Because if you don't, you're destroyed. It's over. Hasta la vista, baby. And then you could, people know how to multiply and add without YouTube. Watch the laziness of this one. It says synthetically divide. Now, I changed the question, so I'd have to see this, whatever. I'm just going to leave it. Watch this. Negative 5x what? cubed plus negative 20 x squared plus negative 80 x plus negative 317 plus negative number over. Now this has to be x minus 4 because I changed the question. And I have to see that in your work and I'd be okay with it. Really think you should make that factor what I just said there. I think you should do that. Okay? And that's your answer. That's your answer in fractional form, right? So remember, read your directions. What form do they want? Now, it's time to go back up to this. Oh, we got chock full of notes today, all right? So you better be ready. Remember this answer? Remember this one, number 4, or your whatever example you call it? I don't really care what you do. Your notes. Let's synthetically divide with this one. What goes into blank? What goes into blank? It's not negative 1. Negative 1/2. It's the 0 that corresponds to the factor. So negative 1/2 goes into blank, and then you put the coefficients here. 4, negative 8, 2, negative 1. And then let's make an extrapolation, because synthetic division does work for any division by a linear binomial. What does that mean? X to the what power? 1. That 2 is an issue, though. As a fatter Mac, look at what happens right off the bat. What do you do first? Pull down 4, and we're already wrong. Patience, young Jedi. What's negative 1/2 times 4? Negative 2. Negative 8 times negative plus negative 2 is what? That's wrong, but I see something. Negative 1/2 times negative 10 is what? 5. 5 plus 2 is? That's wrong, but I see something. Wait till you see this. What's negative 1/2 times 7? Negative 7/2, and this is negative 2/2. This is weird. What's negative 2/2 minus 7/2? I see something. That's actually spot on. Isn't that strange? What are all the coefficients of the answer, though? They're all off by a what? Half. Oh, I missed. There, I got it. Look at the number in front of the x. What's the number in front of the x? 2. So what can you do with all of these to get the right answer? Divide by the number that is in front of the linear binomial x term thing, leading coefficient. I could not have said that any better than I wanted to. Divide by 2, divide by 2, divide by 2, x squared, x. But then what's strange about the remainder? Do nothing. Can you remember that? I don't know. So sometimes I say maybe it's better to just do long division when your linear binomial does not have a leading coefficient of 1. Your call. And we'll talk to the computer as you're getting ready. This is called the remainder theorem of synthetic. Actually, this is now called synthetic substitution. We could call it synthetic division up above because it took the place of dividing. But also synthetic substitution is a thing. It's the same process, but there's a different analysis of the answer. So look at what we're taking the place of, and I'm trying to get you to understand the directions in the book because it can be complicated. I'm not saying it's bad, it's just complicated. And I'll tell you what it means. So off to the left is some basic Algebra 1 work. What I took was this polynomial x cubed blah, and I plugged in negative 2 for x. Substituted, some would say. Actually, everyone should say. And I got 2 for an answer. Easy math. And I understand that the next thing I'm going to show is a little bit longer than this. But you're going to need to know this application whether you like it or not. Did I say good morning, by the way? Good morning. So, first of all, understand x minus k is a what? What's x minus k called? Starts with an F. Probably don't know what I mean. That's a factor. So k equals negative 2. What's negative 2? Is that a factor or is that a 0? That's a 0. So the reason I bring that up is what goes in here? Negative 2 or 2? And the answer is negative 2. Don't get confused. When I have a factor, then if it said x plus 2, then negative 2 goes in there. But they're saying k equals negative 2. Not using the term 0, but watch what happens when I synthetically go through the process of what I'll call synthetic substitution instead of division. By the way, what's next? This is what kills students. 1, 0, negative 3, 4. We're missing a term. You like right answers. Get the missing terms put in there. 1, negative 2, 4, 2. This is what the remainder theorem says. The remainder of a synthetic substitution statement equals the output if I would have substituted that value in for x. That I did say the way I wanted to say. I don't know if I can do it. The remainder, this is going to be tough. The remainder of a synthetic substitution statement equals the output value if I would have plugged that same number in for x and evaluated. I think I changed it a little bit, but... Whew. Okay. Now we go on. This is day 2 because I just used my notes from the regulars and it's fine. Because we split this out in 2 days and really try to... We're going to do it in 2 days, but we're going to really expand on a worksheet and really try to hammer this stuff down. So the next thing we're going to have, and it's within the same section, you'll be able to deal with it, and we did do this last year. Yes, 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 yes. But what I want to make sure, and this book wants to make sure, that's why I cut this out years ago. Actually, 2008, that's a long time ago. See that date? Isn't that funny? Rational zeros theorem. We got to remember what a rational zero is. A rational zero is this yellow that I have highlighted here. Okay, I just circled it. So 4x squared minus 9, if you found the zeros for that, you get 3 halves and negative 3 halves. Rational, can be expressed as a fraction. The next one, x squared minus 2, that's weird. This is called factoring over the irrationals. This could be considered a difference of 2 squares. What's the perfect square of 2? What times what equals 2? Say that number. Square root of 2 times the square root of 2. All right, but then what are the zeros? Negative root 2 and root 2. Those are irrational. There's one more type of zero that comes from this. What kind of zero do I get out of this? Imaginary. So there are really 3 types of zeros you can run into. The rational zeros theorem only covers the rational type of zeros. And that's what you need to understand when we actually show you this. Now, I tried to explain the book. I don't rip on the book. I just told you, though, it's a tough read. That's all. Because I think if I showed someone this thing I have circled up here that I'm pointing at, you may or may not understand it very well. And I would understand that. But look at what this x has. X to the nth. Do you see that? Then the next one has x to the nth minus 1. What does that mean the degree is of this polynomial? Who's higher, the x to the nth or the x to the nth minus 1? X to the nth. So this just means this is the leading degree. This is the degree of the polynomial. It's n. So what does that make a sub n? The leading coefficient. That's all that this notation is. And the n minus 1 just means everything goes down 1. And then the a sub 0 is actually called the what? Constitution. What? Constant is what we were looking for. Do you remember P over Q? Well, this is what it says. The biggest word right here is underlined. Everyone say it. Possible. These are the only possible rational zeros for a given polynomial. And then every book I've ever seen uses the letters P over Q, plus or minus. So I get a polynomial, and you're going to be hung out to dry. You're just going to have an x to the third and x to the fourth, and I'm just going to tell you find the zeros with no information. We're like, what do I do? I just start trying numbers. All right, what numbers do I try? All of them? No. You do a P over Q list to limit an infinite amount of possibilities to, in some cases, 2, 4, 6, 8. Who do we appreciate?
P over Q.
So we appreciate P over Q, exactly. Sorry for hitting you with the pen. All right, so all factors of the constant go up in the numerator. All factors of the constant go in the denominator, and you do all combinations of numerator over denominator. That's your list. And then what do you do with that list? You try them and see which ones work. That's what you do, and we did this last year. Do you remember that? Okay. What are the factors of the constant? 1. What are the factors of the leading coefficient? This is ridiculous. So what is the only possible zeros that are rational? Did you notice I put a plural on there? What are you supposed to put in front of this? Plus minus. So this silly little polynomial, this silly little polynomial has only 2 possible rational zeros. And what if neither one of them work? Then what kind of zeros does this sucker have? Irrational or imaginary. Weird. So we put 1 here and we test it. 1. What's next? What's next? No time for this. What's next? 0. And then 1. That's why I was waiting for you. Then you bring down to 1. 1 times 1 is 1. And then negative 2. And then, you know what? We use the remainder theorem that I just taught you. The remainder theorem says that this is like plugging in 1 and getting negative 1 for the output value. So is this a 0, yes or no? No. 1 comma 1, negative 1, is a point on this graph. That's what the remainder theorem that I just showed you on the last part of the notes says. So what this says is 1 is not a 0. All right, then we try negative 1. 1, negative 3. 0, 1. It's annoying to have to keep rewriting this, right? What if you had to test like 5 of these? I'm going to show you a different way of doing synthetic division, substitution, whatever you want to call it. Is this going to be a 0? I can already tell. Is it? Is it? Is it? No. Hope I did that right. I felt like I went too fast. So what that means is negative 1 comma negative 3 is a coordinate. This is not a 0, so there are no rational zeros. So that was a silly one. It says find the rational zeros. There aren't any, because the only possibilities were 1 and negative 1. That's what P over Q. What's P, everybody? What are the factors that you don't do? It's not what you do in the toilet. That's ridiculous. What's P? 1 and what? The factors of 2. You guys are killing me, Smalls. What's Q? I got it even color-coded. What's Q? 1 and 3. Now, this is what you should do. Then you turn this into all combinations of numerator over denominator. And I'm lazy. Put plus minus parentheses. It's all plus minus these. Okay, but looking at the directions, it doesn't say, and please read your directions tonight. Listen to this. Look at me. Look at me. Listen with your eyes. No, that makes no sense. But if the directions say find all possible zeros, then what do I just have to make? A list. And then you're done and move on. What's not in this directions? Possible. So it says find the rational zeros. But we are going to make our list first. 1 over 1, 2 over 1. And if you're going to make your list and it said possible, just put plus minus out in front. So you don't have to write plus minus a million times. And then 1/3, yes, and 2/3. And I hope you understand how you do that. You just take each numerator over each denominator and get all your list done. How many possible rational zeros are there? Don't say 4. 8. You know what there used to be before this? Starts with an I. Infinite. So that's the power and beauty of P over Q. Who are you going to try first? 1. And your book is usually nice. So, bring down 3. Stop. Hammer time. I've just shown a new way that I showed my students last year because this may be trial and error. I don't want it to keep rewriting 3, 4, negative 5, negative 2. So this is another way of doing synthetic division. I'll do them both at the same time to show you what I mean. So this is what you'd have to do if you wrote it every single time. What do you do first? What do you do first? Bring down to 3. Well, guess what? I brought it down. What do I do next? I take 1 times 3, and then 3 plus 4 is... See, I have faith in my students that they can do this. 1 times 3, 3, 3, 3 plus 4, 7. They can hold that in their mind just for a second and actually just do the adding. I hope I'm right. 1 times 7, 7, 7. 7 plus negative 5 is what? I have faith in you. Oh, are you excited? 1 times 2 is 2. 2 plus negative 2 is what? Well, I'll be darned. The book was nice. What do the directions say? Find the rational zeros. So one of them is 1. How do I get the other 2? Well, this is it's off to the side, depressed polynomial. What can I do with that depressed polynomial? It needs to be worked with. It's depressed. And how would you work with it? Factor it. For the love of whatever you believe in, please just unfoil this. It's got to be 3x and 1x. And then all you have is 1 and 2. Ooh, which one goes where? What is it? 3x plus 1 or plus 2? It's plus 1. And then x plus 2. And then I could just check real quick. 3x times 2 is 6x. 6x plus 1x. And then this is equal to 0. So what are my other 2 zeros? What are my other 2 zeros? Negative 2 and negative 1/3. And lo and behold, are those in my list? Are those in my list? So again, understand the difference between possibilities and actualities. These are the actual zeros. These are just the possibilities only. Is everyone okay? You've drifted. What time is it? All right. This one's a jerk question. Because guess what happens when you try 1, negative 1, negative 2, 2, 3, negative 3, 6, negative 6. None of them work. And I used to do this to the old school students back in the day. By hand, before graphing calculators. Can you believe that actually existed? Time without graphing calculators? Then the first one that works is 3 halves. Ouch. So guess what? I just mentioned what might help you on these instead of P over Q. Although I do want you to know P over Q. What might help you to get your list taken care of real fast? Go ahead and put it on my desk. Graphing calculator. You could go to the graphing calculator, see that 1.5 or 3 halves is an x-intercept. And of course, x-intercepts turn into zeros, which we could turn into factors, but we just need the 0 part. And then you could take that 3 halves on the graphing calculator, pull it out on your paper, and then actually synthetically divide to prove that it is a 0. And this is mandatory. So that's what you would have to do. Prove it, and then take that depressed polynomial and get the other 2 zeros. By the way, those other 2 zeros are what kind of zeros? Irrational. Okay? So here's one right out of the book. Again, I love the notes like this. I don't care what anyone says. Gives you exactly what you have to do on 26. If it's assigned. So here we go. We got this polynomial, 5x cubed. We can play the P over Q game. Factors of 51, 1, 3, 17, 51. Factors of 5, 1 and 5. And then this is not really that you cannot write this as a final answer if I ask for possibilities. You actually have to list plus or minus 1, 3, 17, 51. 1/5, 3/5, 17/5, 51/5. Spitting all over my screen. But then what you can do is this. Yoink. And actually, this is not your graphing calculator. This is the book. And then use your eyeballs. What does that look like right there that it's crossing? 1. What does that look like it's crossing? We may use either one of these. What does this look like? It looks like a fraction. So I'm not going to use this one. I'm going to use 1. And I'm going to prove that 1 is a 0. So I take 1 from the looks of I don't even need to do the 0 feature. I say, hey, it looks like it's crossing 1, the x-axis, so that means 1 should be a 0. Bring down to 5, no time for this. You get it, you know how to multiply, get ready to get excited. And hallelujah, that's awesome. All right? Now, by the way, stop. What do the directions say? Watch them. So completely factor, what does that mean if 1 is a 0? What is one of the factors? It's not a big deal. You just better read your stinking directions today and answer the questions that they're asking you. But wait, there's more. Stop. What is this, maybe? This is -3, so actually this depressed polynomial is already half factored. You already said x plus 3. What does that leave? Good FOILers are good factors. 5x? Huh? Minus 17. 5x squared, -51x, and then -17x and 15x, -2x. Boom shaka, laka. By the way, what does that mean? I don't know what that green thing is. What does that mean the 0 is? 17/5. You got to be careful on finding that 0 because 17/5 does not turn into x minus 17/5. What's the leading coefficient on the answer up here? What's the leading coefficient on the answer up here? Or the question, I'm sorry. 5. So if you had x minus, x plus, and then x minus 17/5, that doesn't match the question. You have to convert that to 5x minus 17. Does that make sense? Arr. How many times do you have to depress this? It's so sad. How many times do you have to depress this? Twice. What time do we get out of here? People are frantically looking at the clock. Oh my goodness. Okay, so when we look at this graph though, you do not need to use the 0 feature, I wouldn't think. I would think you'd be able to look at this and say, ooh, that one looks like it's at -1. That one looks like it's a little bit off, like a decimal. And then this one looks like it's at 2. Although I did do that. I found them. So I think by looks you can actually depress this polynomial, but this is mandatory that you go off to the side and actually do the depression work. So 1, -1. Are we all okay on this? You get it? 5, and I guess I left 10 from a year ago. Or from 2008. 1, 10, 0. Is that a 0, really? It's freaking me out. 0 plus -7. Let me just do this offline. I'm a maroon. Greatest notes ever. Okay, got it. All right, then I synthetically divide by 2. But who do you synthetically divide into? The original 1x to the 4th? No, because you're creating just a new x to the 3rd. You have to double depress the polynomial. You need to take this new polynomial that you got and depress that again. And then you get, I hope I do this right, 2, 0, right? Okay. -5, -10, 0. Okay. And then, so what are 2? Okay, this is back to the directions of finding zeros. So just be careful when they say factor or zeros. So 2 of my zeros are -1 and 2. And then this is x squared plus -5 equals 0. So what are my last ones? Plus minus what? Square root of 5, which are what kind of zeros? Irrational, which would not be on the list. Okay, and then I did kind of shove this last one, but there's 1 minute left. I don't think the homework even incorporates this, so this is something we could talk about tomorrow. Thanks for listening.